Hi everyone, so this video is about partitioning a directed line segment, also a little bit of midpoint formula. To get us started, imagine you're using a computer software to design a video game. This little old school video game here. You want to place a secret buried treasure chest halfway between the base of the volcano, where is that? Right here. So the base of the volcano and the shark. So here's the shark. Where should you place the treasure chest? What is halfway between these two? So what you would need here is the midpoint formula. You would need to know where is exactly the middle between those two. It would be somewhere around here, but how do we calculate that? So just as a reminder, the midpoint formula, all you have to do to find the middle of 2 points is just average the two x's and average the two y's. Add them up, divide by 2. So for example, the midpoint of 3, 2 and negative 5, 1, often you can just kind of figure it out, right? Like if I'm at 1 and I need to get up to 2, then I know the average of that is going to be 1.5 or 1.5. Also, if I'm at negative 5 and 3 and I just find the middle, it's right here. So I know that this is the midpoint. If you don't want to count, then you can do the midpoint formula. So add up the two x's and divide by 2, and then add up the two y's and divide by 2. So that's going to be negative 2 over 2, which is negative 1, and this is 3 halves, or 1.5, which is exactly where we landed here. Let's try another example. This time, you want to make a secret sinkhole 1/3 of the way from the base of the volcano, which is again here, to the shark. So where exactly would 1/3 of the way be? And also, does it matter where you start? Like, would it be this 1/3 or would it be like this 1/3? So that's kind of our goal for today, is to figure out, rather than just cutting a segment in half, how could we figure out some other ratios, like 1/3 of the way, for example. This is used quite often in stuff like game design or construction. Like you want to make a rest stop that's like half of the way to this place and half of the way to this place. Or like Google Maps uses this kind of thing. Okay. It's called partitioning a directed line segment. Let me break that down for you. To partition something just means to cut it into pieces, to separate or divide it. Like this is called a partition, if you've ever seen those around. Also, a directed line segment. So you all know what a line segment is. A directed line segment means it has a direction. So it just has a start and an end, and we're going this way. We have to know where we're starting and ending. If I'm going to say 1/3, I need to know, is it this 1/3 or is it like 1/3 from here or 1/3 from here? So that matters if it has a direction. So it's got a length and a direction. Okay. Also, typically, like say this is segment AB. Usually when we write line segments, we could call this AB, or we could call it BA, and usually it doesn't matter because we're just talking about its length. In this case, it does matter because I need to know where to start and where to end. So don't flip-flop the start and the end. For example, on I-75, which goes all the way up through Ohio, Dayton is at the 52-mile marker right here, and Toledo is at the 202-mile marker. And what mile marker is 2/5 of the way from Dayton to Toledo? Like 2/5, if I cut this into fifths, 1, 2, 3, 4, 5, where would like this be? So one way to figure this out would be figure out the entire length and then take 2/5 of it. So the entire length would be 202 minus 52, which is 150, and then do 150 times the 2/5, and we would get mile marker, that's just the length from here to here is 60. I was at mile marker 52, and then I added 60 more miles, so if I do 52 plus 60, I'm now at mile marker 112. So keep that idea in mind. Here's how we can do this kind of thing on a coordinate grid. So for example, let's say I have this problem. If point P partitions a directed segment, AB, this means this is my start and that's my end, in a ratio of 2 to 3, find the coordinates of P. So first of all, let's talk about this ratio thing. This ratio is not a fraction. 2 to 3 is not the same as 2/3. What this is saying is I actually have 5 total parts. 2 of them at first, and then 3 of them at the end, and my point P is right in between the 2 parts and the 3 parts. So for example, if I say point P partitions it in a ratio of 2/3, I have 2 parts to 3 parts, and point P is actually 2/5 of the way from A to B. So you can see that right here. If I said ratio of 3 to 2, that would be a totally different thing. It would still be 5 total parts, but this time it would be 3/5 of the way from point A rather than 2/5 of the way, because the 3 comes first, then the 2, and so you would have 3 parts and then point P and then 2 parts out of the 5 total. So as we look at this picture here, basically, to get from point A to B, I run 10, so it's like 10 in the x direction, and we rise 15. Basically, I'm just going to take 2/5 of each of those. So like if I split 10 into 5 pieces, 1, 2, 3, 4, 5, that are 2 units each, 2/5 would be right here. And remember, it's a ratio of 2 to 3, so you can see that I have 2 parts to 3 parts. And then if we look at the rise, or the y values, if I cut 15 into 5 pieces, 1, 2, 3, 4, 5, again, I want 2 parts to 3 parts, so right here is where my y value should go. And so that is my answer. Point P would be at -4, -2. Here's the good news. You don't really have to worry about all this mess on a graph, because there's actually a formula that will do this for you. It looks very complicated. Don't be scared though, you just fill in the pieces. It's on your formula sheet, and it tells you in words, first of all, what it is. The coordinates of a point, which partitions a directed line segment, AB, so A is the start, B is the end, at the ratio of A to B, so it's going to handle the ratio part for you. A is going to be the first thing in your ratio, B is the second number in your ratio, from the point x1, y1 to x2, y2. So all you have to do is fill in the 2 points, the beginning and end, and your ratio. There are actually 2 formulas that do it for you. I like this second one because it makes more sense. This second formula basically says, take your first x value and then add on a portion of whatever the x distance is, which is kind of like what we did here. Start with your x value and then add on 2/5 of whatever the x value is, and then start with your y value and add on 2/5 of whatever the y value is. Note that the formula has a comma in the middle. This is going to give you 2 separate numbers. This will give you the x coordinate, and this will give you the y coordinate. If you like this formula better, and really they're about the same as far as easy goes, if you like this formula better, again, there's a comma in the middle. This will give you the x coordinate, and this will give you the y coordinate of the point that you're looking for. So for example, if you have a directed segment with endpoints 1, 4, and 4, 10, so this is my x1, y1, and this is my x2, y2. Find the point which partitions a segment into a 3:5 ratio. So here's the thing. This is my A and this is my B, because it said a ratio of A to B. So you don't even have to worry about turning this into a fraction. Like obviously this is 8 total parts, and so it's going to actually be 3/8, but the formula does that for you. This is the second formula. So watch, when I plug stuff in, x1 was 1, and then I'm going to do A, which was 3, over A plus B. A plus B was 8, because I just did 3 plus 5. If you want to put 3 plus 5, that's fine. But notice that this little A over A plus B turned it into the 3/8 that I was expecting. And then I'm going to do x2 minus x1, so 4 minus 1. And that's the end of the x coordinate. So comma, and then we do all the y stuff. y1, which is 4, plus, again, A is 3 over A plus B, which is 8, and then y2, 10, minus y1, 4. And that is it. So let me get my calculator. We're going to do, I'm just going to type all of this in. So 1 plus 3/8 times 3, which is 2.125. And then I'm going to type all this in. And I got 6.25. So this is a point that would partition the segment from this point to that point. This would be exactly 3/8 of the way. So in a ratio of 3:5. If you want to use the other formula, that's fine. You do it the exact same way. You still just fill in this for A, fill in this for B, fill in this for x1 and y1, and fill in this for x2 and y2. It really doesn't matter to me which one you use. So if you want to use this one, you would fill in, B is 5 times x1, which is 1. I feel like I'm on a bit of a scavenger hunt sometimes. A is 3, x2 is 4, and that's all over B plus A. And B plus A would be 8. Comma, and we'll do the y ones. So B is 5, y1 is 4, and then A is 3, y2 is 10, all over, again, B plus A, which was 8. And let's make sure we got the same thing. So 5 plus 12 divided by 8. Yep. I once again got this. And let's do 20 plus 30 divided by 8, which, yep, same thing. So we get the same thing that we got on the other side, just using this other formula. Make sure you do all of this first or in parentheses, then divide it by 8, or otherwise the calculator will get it wrong. All right, I wanted to show you one final thing that may kind of trip you up on this kind of problem. So on this one, it gives me my 2 points. So this one is x1, y1, oops, y1. This is x2, y2, and I want to find the point that divides the segment 2/3 of the way. So it didn't actually give me an A and a B, it gave me 2/3. So you have a couple options here. One is you can use the second formula and just fill in 2/3 rather than A over A plus B. You could just fill in 2/3. So for example, you start with x1, so 4 plus, and then you would just do 2/3 of x2 minus x1. And then you do the same thing for the y, start with y1, and then add 2/3 of y2 minus y1. So rather than do the A over A plus B, you could just fill in 2/3. Or, if that is psyching you out, you could turn this into an A and a B by figuring out what the ratio would be. If I'm cutting a segment, it helps me to draw it out. If I'm cutting a segment into thirds, there's 1, 2, 3 pieces, and I want to be 2/3 of those, so 2/3. Basically, what would that ratio be? Well, it would be 2 pieces compared to 1 piece. So it would be a ratio of 2 to 1, which is 2/3 of the way. Basically, they'll have to add up to 3. So if you want, you could figure out what the ratio is. 2 would be your A, 1 would be your B, and then in the formula, when you do A over A plus B, you could just fill in 2 for A, and then you could do A plus B, which is 2 plus 1, and you would end up getting the exact same thing, 2/3. So either way, whatever makes the most sense to you. And if you're using the first formula, you would have to do it this way because you would have to figure out what your A and B are. That's kind of why I like the second formula better. And that, I believe, is the end. Oh, just one other thing here. On this particular problem, we want a point to be 1/2 of the way from A to B. 1/2 of the way, if I cut a segment in half, would actually be a ratio of 1 to 1. That would be my A, this would be my B. So you could fill all this information into the formula using 1 for A and 1 for B, but actually, if you want to figure out 1/2 of the way, you could just do midpoint formula, which is probably easier. Okay, I'm gonna not go through that full example.